Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is construct string from binary tree. So the problem, the statement, I was not able to understand in the first go, but I'll tell you what it says. So let's say we have this first tree. Now what we essentially have to do is we have to represent the tree, the pre-order traversal of the tree in a string format, right? So I'll tell you how you will represent it. First of all, you have one, right? So we directly write one because it is pre-ordered. So that is why I'm accessing the root first. So now I visit the left child and the right child. So the left child and the right child are going to be represented inside these brackets, right? Both of the left child and right child. So let's say this is left child and this is right child. So this will be the general format for every node, right? That first of all, I'll have this particular value of the current node. Then I will have the left child inside brackets and the right child inside brackets. So this is the case when both the left and the right child are present. Now what happens if only the left child is present? So let's say this is the root value. I'm going to write the left child inside my curly braces and leave the rest as it is, right? Now I'll not write anything after it. Similarly, if only the right child is present, I cannot write it like this, right? Because then there will be no difference between these two methods and I will not be able to understand whether this is the left child or the right child. So what will essentially happen is I'll have to leave a blank space like this and then write the right child. Right, so this is the case when both the left and the right child are present. This is the case when only the left child is present, and this is the case when only the right child is present, and when none of the children are present, then I can just write the node value. Right, so this is how you should write this part. And what about these values inside the left and the right? What I've just directly written left and right now will be replaced by a recursive function, right? So you don't actually need to worry about what will go inside. You can just call your recursive function on the left and the right subtrees respectively, and the recursion will take care of everything. So if I just show you the code is also very simple. It's just what I said right now. If the root is null pointer, I'm just going to return an empty string, and I've initialized my answer with the value of the current node. So I've converted it into string and I've stored it into answer. Now if both of the children are present, I'm going to have the left subtree inside these curly braces. So I've started this curly brace, I've started this bracket, and then I have called my recursive function on the left subtree, then I've closed the bracket. Similarly, I've started the bracket again and I write the right subtree with the recursive function and then close the bracket. So you see, I'm not worrying actually about what will happen when I call this function. I'm just recursively calling it and assuming that everything will go fine, right? Now I have this left check if root of left. If both of them were true, then it is good. That now if this condition is not satisfied, there are three cases. Either the left subtree is present only, or only the right subtree is present, or none of the subtrees are present. So I have to take care of these two cases when at least one of them is present. So if only left is present, I'm going to start my bracket traverse to the left subtree and then close my bracket. If only right is present, I have already told you I have to leave an empty bracket and then start a bracket. I need to have the right subtree and then close the bracket. If none of them are present, I don't need to do anything. That is why I don't have an else condition here. And at the end, I can just return my answer, and this would be the solution of this particular problem. So basically, it's just a simple recursion and trusting that your function will do everything, and you just need to worry about the current case and the base case. So if I just submit this and show you that this particular solution works, so you see it is passing all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.